Hello everybody, this is Mr. Fager coming at you for some notes on the substitution method for solving systems of equations. If you're watching this, you're either in my Algebra 1 class or my Analytical Algebra 2 class. Today we're just doing more of our algebraic workup, and we're talking about the second method for solving systems. Hopefully you're watching this at home. It's an e-learning day. You're going to get it done. And I'm going to try not to take too much of your time up, but we got to get through these notes and refresh you on this method. So let's get started. Today I'm using a different program than we're used to. I'm using my Explain EDU. This is a free app that we can get on our iPads here in Elkhart Community Schools. So let's see how it works. I know I'm excited to try it, but I also was at school kind of late, so yeah. Well, let's just get into it. I'm taking up too much time. Anyway, substitution method. What is it? Well, it's a method. Ooh, better yet, maybe I could use text. I'm sorry that I'm not writing this. I know I'm going cheap. It is a method of solving systems of equations, right? Because that's what we're talking about. Remember what systems of equations are. Those are groups of two or more equations with the same variables. So a method of solving systems of equations by substituting equations within one another. Right? And however you write this in, however you put it in, this is really what the definition of substitution method is. It's a method of solving systems of equations by substituting equations within one another. So what does this mean? Well, we have our nice steps. We have 3 handy steps that are going to help us along our path. I'm going to change this up just a little bit. There we go. So step 1. This is important. The first step, the base. Solve one equation for x or y. We want to solve for x or y to get started, so that way we know what we can sub in. So we're going to have x equals all this stuff over here on the left, or we're going to have y equals all this stuff over there on the right. We want to get x or y by itself. Number 2, step 2. As you can imagine, we're going to substitute, hence the name of this method. If you want to put sub, I'm okay with that, or just substitute. That's supposed to be an I. Substitute. We're going to substitute this expression into the other equation and solve for that variable. All right. Step 3, we're going to substitute again our answer. I'm going to put substi for short. So substitute your answer into the revised equation from step 1, and we're going to solve for the other one. We're going to solve for the other variable. I know it's a lot of words right now, but we're going to see some examples. Excuse me. We're going to see some examples real quick here. We have 10 examples to go through. Like I said, I'm going to try not to take up too much of your time. If I find that we've done enough examples, you should have a good footing. We can also end it there, and I'll just get you going on your homework that will follow this. So, think you got it? If you need to pause the video, you can do that. But we're going to go ahead and move on to the next. So we're going to do our first 3 examples. Nice thing is about substitution, remember that first step. We're just trying to get x or y by itself. And the nice thing about number 1, both of these are by themselves. So we know what y equals over here, and we know what y equals here. Well, the nice thing is, since these both are equal to y, we can actually set these up equal to each other. So I'm going to substitute 4x minus 1, this right here, in for the y here, since that's what y equals. So I have 4x minus 1 equals 2x minus 5. Did you hear me? Did you see what I did? All I did was took this, since y equals the 4x minus 1, I took it and substituted it in for this y here. Now it's all about solving for x. X is the only variable I have. To do that, I need to get x by itself. So I'm going to subtract x from both sides, or in this case, 2x. These cancel and go bye-bye. And I'm going to bring my work down over here. So 4x minus 2x is just 2x minus 1 equals negative 5. Now I have just 2 steps left to do, right? Because I want to get x by itself. And I'll be able to plug this into the original thing back up here when we get there. 2x minus 1. Well, to get x by itself, I have to add 1 to both sides. Let's start there. Just like the Halloween movies, we pick off the loner. They're so easy and they're so alone. I know that's not because I know from experience. So I have 2x equals negative 4, right? Because negative 5 plus 1 equals negative 4. To get x by itself, we have to divide because we are multiplying, right? So x equals negative 2. That's one of our solutions. That's part of it. That's part of it. Now, step 3. We're going to substitute this answer. This is our answer. We're going to substitute it into the revised equation from step 1, and we're going to solve for the other variable. What does that mean? Let me clear things up, and I'll show you. All we're doing now is we're taking this x equals negative 2, excuse me, and plugging it in for x all the way over here. So we know that y is equal to 4 times this negative 2, because that's what x equals, minus 1. Simplify that. Y is equal to negative 8 minus 1. Y equals negative 9. So our answer to number 1 is negative 2, comma, negative 9. Remember that our answer for a system of equations is an ordered pair. We want it to be x comma y, right? Make sense? Cool beans. So the nice thing about 2 and 3 is also that they have a y equals something. I think I'm going to do this next one in a different color. I like switching it up. I think I'll do a green. So the nice thing, like I said, we've already got that y is equal to this 6x. That means I can take that y and plug it in for the y here, because we know what that y equals. So let's do this. 2x plus 3 times y. Remember that 3 is separate from the y. I have to plug in 6x here, where y is, and this all equals negative 20. Then I just do the multiplication here. 2x. 3 times 6x is 18x. This equals negative 20. And I kind of want to check just to make sure that I wrote that down right. Yes, it is negative 20. So then, next step, combine like terms. And that means I get 20x equals negative 20. Well, you know what that means. X is going to be equal to the negative 20 divided by positive 20. And that equals negative 1. So we know that part of our answer is negative 1. I'll make that as straight a 1 as I can. And step 3, we're going to take this whole thing, x equals negative 1, and we're going to plug it right back into the first equation we used. So y is equal to 6 times that x. X is negative 1. Y equals negative 6. That's the other part of our answer. Pretty easy so far, isn't it? It'll get a little bit more challenging, but it's nothing that we can't handle, right? We are capable mathematicians. Number 3, we're given that y is equal to x plus 9. That means I can take x plus 9 and plug it in for y here. So I have 3x plus 8 times x plus 9 equals negative 5. Now this is going to require a little bit more work because we have a binomial. It has 2 terms here, term 1 and term 2. And that means that I'm going to have to distribute. So I'm going to take this, I'm going to plug it into here. So 3x plus, we have to take 8 times x, which is 8x, and then 8 times the 9, which is 72. And that all equals negative 5. In this next step, I'm going to do 2 things, so that way we're saving some time. We need to combine the like terms, 3x plus 8x, which gives me 11x. But I'm also going to subtract 72 from both sides. That way I get the 72 over to the right side. I'm one step closer to having that x alone. Negative 5 minus 72, negative 77. And if I divide by 11, x equals negative 7. So You know what that means? Negative 7 is part of our answer. Since it's x, it goes in the x spot, right? X comma y. Now, the only thing left to do is take this x equals negative 7 and plug it back up into the first equation, which, if we remember, is going to be y equals that x plus 9. So y equals x, that's negative 7, plus 9. Y equals positive 2. These are the first 3 examples, but there's still a few more to do. They're not always going to be easy like this. So let's see what we have. Example 4. This time it's backwards, and we have to pay attention to this. Now, I have that x is equal to this 4y plus 7. Well, we have what x equals. X is alone. That means I can take this equation, 4y plus 7, and plug it in for that x. So, let me do that. 2 times x, which is 4y plus 7. Whoop, don't know where it went. Minus 6y equals 12. And because this is a binomial here, the 4y plus 7, I'm going to have to distribute. But that's nothing that we can't do. 2 times 4y is 8y. 2 times 7, positive 14. We've still got minus 6y, and we've got the positive 12 over on the right side. I'm going to do 2 things once again in this next step. I'm going to combine the like terms, so the 8y and the negative 6y, which is positive 2y. And I'm going to subtract the 14 from both sides. Well, guess what? 12 minus 14 is negative 2. Now, I know what you're all thinking. Hopefully, you're saying to yourself, well, this is 2 times y. So to get y by itself, I have to divide by positive 2. That undoes the multiplication, and y is equal to negative 1, right? Because negative 2 divided by positive 2 is just a negative 1. And that means that our y value is negative 1. We still need to find out the x, but the nice thing is step 3. We take our answer, and we sub it back into here for y. So where I see y, I'm going to put parentheses. So x is equal to 4 times that parentheses, negative 1 plus 7. 4 times negative 1 is just negative 4. And when you add 7, x equals positive 3. How about that? There's our solution. Now, the only reason I might be nervous, or you might be nervous, about number 5 is because we don't have x or y by itself. So that means we have to get one of the two by itself. Ooh, need a drink. In this particular case, don't freak out. Notice, try and figure out which variable could go by itself quickly. In this case, notice that there is no negative or number in front of the y. That means that y is going to be very easy to get by itself. So to get y by itself, I can subtract, I'm going to do this in a different color before I continue. I'm going to subtract 2x from both sides. So when I do that, let me get this, y comes out to equal that minus 2x minus 2. Does that make sense? Because y had no numbers in front of it, I used that and said, I want to get y by itself. It's going to be the easiest to get by itself. So I just subtracted the 2x to the other side. One step. Now, I have what y equals. Y is equal to negative 2x plus 2. And you know what that means? I can plug it into this equation. So 5x plus 3 times y. Remember that y is? It's negative 2x minus 2. Now we just go about solving. And this is still equal to negative 8. Ooh, I almost forgot that. I feel like Taylor would be the one to call me out. So from here, we still have the 5x, but we need to distribute that 3. So let's go ahead and do it. I've got 3 times the negative 2, that's negative 6x. 3 times the negative 2 is another minus 6. This equals negative 8. Same thing. In one step, I'm going to do 2 things. I'm going to combine the like terms. So 5x minus 6x is negative x, or negative 1x. And I'm also going to add 6 to both sides. right? So that way this cancels out. Negative x is equal to negative 8 plus 6, negative 2. And I'm just going to divide by negative 1 because we want that positive 1x, don't we? Right? Negative and a negative cancel out. 1 and a 1 cancel out. All I'm left with is x. X equals negative 2 divided by negative 1, positive 2. So we know that I've got 2. I need to find the other one. Nice thing is, step 3, if you keep looking at that. I get to substitute this x equals 2 back right into here. So I'm going to come over here and say y is equal to, notice I'm like right over here. Y is equal to negative 2 times x, negative 2 times x, which is 2, minus 2. So let's do the math there. Negative 2 times 2 is negative 4. And then minus 2, y equals negative 6. Does that math make sense? Hopefully it does. But this is our solution. Remember, just a reminder, if you see something like this, where we have both x's on one side and the y's on the same side, we need to look for what's simplest. Look for a y or an x that doesn't have a coefficient or a negative. Now, we're not always going to see something like that. What we might see are items more like here. Let's see, I think we will get to something like, oh, never mind. These are all very nice. Why? Because in each of these, I can find a variable. Let me see if I've got this. I can find a variable that is already by itself. Remember, this is what we want to look for. We want to find a variable that's already by itself. I'm going to switch over, switch colors up. Oh, I'm going to go golden. Let's go lions. So I want to get y by itself for here. And since there's already a positive 1, right, I just need to get the 2x to the other side. I hope you're thinking it already. You're going to have to subtract. So subtract 2x from both sides, and we get that the positive y is equal to negative 2x plus 9. Well, this is the equation that we're going to use then. Now that we know what y equals, so equal to that negative 2x plus 9, I can take it and plug it in up here. So 2x minus 3y, remember what y equals. It equals that negative 2x plus 9. And it equals negative 11 total. Once again, seeing as we're looking at this, we're going to have to distribute this negative 3. So I get 2x, negative 3 times negative 2, well, that's a positive 6. That's 6x. Negative 3 times positive 9, however, is a negative 27. And this equals a total of negative 11. Yet again, I'm going to do two things, one step. Combine the like terms, the x's. 2x plus 6x is 8x. Then I'm going to add 27 to the other side. All right, and let's see what we get. So these will cancel out. Negative 11 plus 27, well, that's going to come out to be positive 16. And I know you're already thinking, well, this is 8 times x, so I have to divide by 8 to cancel out the multiplication. What I do to one side, I do to both. And 16 divided by 8 is just 2. So we already know that part of our answer is 2. It's going to be an ordered pair. I have to remember it. Now to find what y equals, because we already know what our x equals, we just have to take that x and plug it back into this equation. So y is equal to negative 2 times x, which is 2, plus 9. Negative 2 times 2, negative 4. Add the 9, y equals 5. How's that? So negative 2 comma 5 is our answer for this one. It's our solution, right? That's an ordered point. It's an ordered pair. Coordinate point, I should probably say. Now in this one down here, we have a little bit different situation because the x is the one by itself. Doesn't matter. We still want to get it by itself, so we need to get rid of the 5y. Subtract that 5y from both sides. That way you get x completely alone. We want it completely alone. X equals negative 5y plus 4, because that's a positive 4, right? Now we've got x completely alone. It's a positive 1x. It's all alone. You know what that means. It's time to substitute. Substitute it in here. And we have what? Ooh, 3 times x. Remember what x is. It's that negative 5y plus 4 plus 15y equals negative 1. Remember that in this case, when we plug in the x, we have all y's. Y is the only one left over now. So let's solve. We're going to have to distribute that 3, because it's outside the parentheses. 3 times negative 5, negative 15. Don't forget the y. 3 times 4 is positive 12. I also have a plus 15y and equals negative 1. I can already see that this is going to be interesting as it is. I'm going to have to double check to make sure I did everything right. Ooh. And as I keep this up, I'm just checking over here to look at this. Ooh, okay. I like where this is going already. So, notice something right now. Notice that the positive 15y and the negative 15y are going to cancel out. That's very important. They do cancel out when you combine them. So 12 equals negative 1. This is a question for us to answer. Does 12 equal negative 1? And what you should be saying to yourselves, no, it doesn't. It never equals negative 1. So we have no solution for this. Now you can put no solution or you can put parallel lines. They basically mean the same thing. But these two equations are essentially the same line. They're at just different points. Excuse me. They're not the same line. They're just two lines that are running next to each other and they're never going to intersect. How boring is that? All right. Number 8. We may call it quits depending on what we're looking at. But it looks like 9 and 10. I'm looking at number 9 and 10 on a separate screen. They'll still be similar to this. So we'll end at number 8 and we'll get you on your way. X is by itself. Remember, we're looking for x or y to be by itself. And x is pretty darn close. We just have to get rid of that 4y. So it's positive. That means I have to subtract. So let's subtract that 4y from both sides. X is equal to negative 4y plus 0. If you want to just leave it as 4y, that works fine. But in either case, that means I get to take this and plug it into x here. So let's take that and plug it in for that x. So 3 times x, negative 4y. And we're going to add the 2y, which equals 20, right? Now multiply. Negative 12y plus 2y. Oh, we picked an easy one to end on. Good job. Negative 12y plus 2y equals 20. All we have to do now on this left side is combine like terms. I'm going to bring my work up here. I don't know about you. Negative 12y plus 2y equals negative 10y. I know you're seeing this already. Where's it going? We want to get y by itself, so we have to get rid of the negative 10. And since we're multiplying, we need to divide. So divide both sides by negative 10. Y equals negative 2, right? Positive 20 divided by negative 10, negative 2. Now all we have to do is, you know it, step 3, plug it in over here. So x equals negative 4 times that y value, which is negative 2. Let me try that again. Negative 4 times negative 2, positive 8. So our answer as a real ordered pair is 8, negative 2. Fun stuff? Hopefully it's not too bad. Make sure you get to the homework. I want you to practice those. At this point in time, I believe if I were to check it out, I'd have to check it out. I want you to go ahead and do 3/4 of the problem, whatever that may be. If I need to look at this and revise it, I can. Let me know. Otherwise, I want you to do only 3 out of every 4. 3 out of every 4 problems that you see. And there are a total of 16. So that means only do 12. Only do 12 of the problems on the homework. Sorry, I was looking at it on another screen as well. Not trying to take up your time. Just do 12 of the 16. Do the first 12. Do 1 through 12. Let's make it simple. So hopefully that sounds all right. I hope you guys have a great day. As always, if you have questions, feel free to email. Nonetheless, have a great afternoon, evening, or whatever time of day you watch this. See you later.